Hi, this is the AP Chemistry 2008 free response question, 2008 Form B, question number 3. So, the question is 0.15 sample of solid lead nitrate is added to 125 milliliter of 0.1 molar sodium iodide solution. Assume no change in volume of the solution. The chemical reaction that takes place is represented by following equation: PbNO3 plus 2 NaI resulting PbI2 plus 2 NaNO3. So the question A is list an appropriate observation that provides evidence of a chemical reaction between two compounds. So you could see from the equation that PbNO3 and NiA are reacting to result PbI2, which is a solid, and also by solubility rules, it is insoluble. So you can say a precipitate forms with an appearance that is different from that of the dissolving solid. Moving on to question B. It says calculate the number of moles of each reactant. So mole of PbNO3 is, you use stoichiometry by 0.15 gram of PbNO3 divided by the mole mass of PbNO3 which is about 331 gram, and this is mole. So it will result in 4.53 times 10 to the negative 4 mole. And for mole of NaI, you use the initial condition, which is the sodium iodide solution has 0.125 milliliter of 0.1 molar. So you know that molarity equals to mole over liter. So in order to get mole, you have to get molarity times the liter. So which is 0.1 mole times, this is in milliliters, so you have to convert it into liter. So it's going to be 0.125 liter, which results in 1.25 times 10 to the negative 2 mole. Okay, moving on to number C. Identify the limiting reactant. Show the calculation to support your identification. So you could just try either way, but I will go with the PbNO3 So if you look at the equation, you can see if you look at the coefficients, 1 mole of PbNO3 reacts with 2 mole of NaI. So you can assume that the mole of NaI used is 2 times 4.53 times 10 to the negative 4 mole, which results in 9.06 times 10 to the negative 4 mole. And as you figure out from the B, we have the mole of NaI is 0.25 times 10 to the negative 2 mole. So you can see that NaI is excessive. So you can say because there is 1.25 10 to the negative 2 mole of NaI initially, PbNO3 2 is a limiting reactant. Moving on to D, it says calculate the molar concentration of NO3 minus aqueous in the mixture after the reaction is complete. So in order to find out the concentration of NO3 minus in the mixture after the reaction, you have to use a stoichiometry. So it's 1 mole of PbNO3 resulting actually I'll make a note. So it's the initial mole of PbNO3 is 4.53 10 to the negative 4 mole. That's 1 mole of PbNO3 and you put 1, and then it's producing 2 mole of NaNO3, and you can see 1 mole of NaNO3 produces 1 mole of NO3 minus. So that results in 9.06 times 10 to the negative 4 mole. And this is not all. Because it's asking about the molar concentration, you have to divide this by 0.125 liter, because it says assume no change in the volume of the solution. So then this results in 7.25 times 10 to the negative 3 mole. Okay, moving on to last question, which is number E. Calculate the diagram below that best represents the result after the mixture reacts as completely as possible. Explain the reasoning used in making your choice. So you can see there is 3 on the top and there's 2, and the first one says no precipitate, so solid of PbI2, solid of PbI2, solid of PbI2, and solid of PbNO3. So when you look at it, you're gonna consider that it's gonna be between firstly the top middle right and the bottom left, but you can guess, you can figure out that the right one will be the answer, because it's gonna be PbNO3, because if you look at the top right, the beaker, it shows that there is precipitate and there's I and NO3 and Na2 plus floating around. And this is the right one because from the previous questions, we found that the PbNO3 was a limiting reactant, so there's gonna be no Pb plus 2 plus ions will be in the beaker, and because Ni and Ai is an excessive amount, it's gonna have the leftover I ions and A ions. So that's why the beaker in the top right corner is the right answer. I'll just write it. So we know that PbNO3 2 is a limiting reactant, and NiH has excessive amount. So the top right beaker shows that there is leftover Ni plus and I minus ions floating around, while the precipitate forms. Okay, that's it. Thank you.